Alright, in this video here we're going to be talking about the graph of the cosine function. Now I just did another video on the graph of the sine function where I kind of took the points from the unit circle and talked about like the input and output for the sine function, and then just kind of plotted those points on the coordinate plane to kind of sketch the graph of the sine function. I'm going to do the same thing here for the cosine function. So if you haven't seen the one for the sine function, you should also watch that one, because the sine and cosine graphs, they're similar to each other, but they are different. So you need to be aware of their similarities and their differences. So you don't have to watch that one before this one, but after this one I would suggest watching the one for the sine function if you haven't seen that one yet. Alright, so for the cosine function, alright, so going to the unit circle, and I didn't put up all the points here along the unit circle that we should be aware of, just because I thought it would get too cluttered up here and too much of a mess and too hard to see what's going on. So I just put up like some of the major points, you know, on the x and y axis, and those will be enough for us to graph the cosine function. So remember, the definition of the cosine function, cosine of t equals x, right? The input, the t value, refers to the distance we're traveling along the circumference of the unit circle, right? And remember, the full circumference of the unit circle is 2 pi, which I forgot to put up there, right? So one full lap around the circle is a distance of 2 pi. And then the output of the cosine function is the x-coordinate of your terminal point. So I travel a distance around the unit circle, that distance is my t value, and then wherever I stop, when I take the coordinates of that point in the xy coordinate plane, the x-coordinate of that point, that's the output for my cosine function, right? So the input is the distance I'm traveling around the circle, the output is the x-coordinate of that terminal point, right? So if you haven't seen the videos that I've done on the unit circle, on terminal points, on the definitions of the trig functions, you should definitely look at those before you watch this one here, because if you don't understand all that other stuff, then what I'm going to say here and how I explain this is probably not going to make a whole lot of sense. Alright, so the cosine value is the x-coordinate of my terminal point. So I want to graph my cosine function. Alright, so I'm going to go to my unit circle. I'm going to start with the t value of 0. Right, that corresponds to, on here, you know, in the x direction, that's going to be my 0. Right, so I'm starting at 0. Well, if I start at 0, I'm not moving around the unit circle at all. Remember, when we're moving around the unit circle, we always start on the positive x-axis, right? That's always our starting point. So 0 is on the positive x-axis, and the cosine of 0 is going to be 1, right? Because the cosine is the x-coordinate of your terminal point. So when I'm graphing the cosine function, when my input is 0, my output is a 1. So I have the point up here, 0, 1. Right? So again, understanding what we're doing here, right? The input, the numbers along the x-axis when I'm graphing the function, those are my t values for moving around the unit circle, right? Because those are the input values into the cosine function. The y-coordinate I have on the unit circle is the x-coordinate of the point, no, sorry, the y-coordinate of when I graph the function comes from the x-coordinate of my terminal point on the unit circle. Right? So it's a little weird when you're doing the cosine function, because the x-coordinate here becomes the y-coordinate here. But remember, the definition of the cosine function says, you know, the input is the distance around the unit circle, right? So our input values are along the x-axis here. That's why all the pi numbers are there. And then the output is the x-coordinate of the unit circle. But the output, when I'm graphing the function, the output is my y value, right? So if you can get that part of it, the rest of this just kind of falls into place, right? So basically when I'm graphing the cosine function, I'm moving around the unit circle, and I'm just plotting all the x-coordinates. Right, so at 0, a t value of 0, my x-coordinate is 1, so I plot the x value of 1. And then when I move along the unit circle and I go up towards pi over 2, right, which is my next key point I have here, well, as I move this way around the unit circle, my x-coordinate is decreasing, right? I'm moving to the left, which means I'm getting smaller and smaller x values until I get to pi over 2, where my x-coordinate is 0. Right, so at pi over 2, my x-coordinate is 0, and as I go from one to the other, it's going to be decreasing. It's going to be going downward, because as I move around the unit circle, I'm getting smaller and smaller x-coordinates. Right? And then as I move from pi over 2 to pi, as I move through that second quadrant, I go from x-coordinate of 0, and I'm still getting smaller and smaller. Now I'm going to negative x values until I get to pi. I have an x value of negative 1. Right? So I'm still moving to the left here. Now I'm moving into negative x values. And so at pi, I'm going to have an x value of negative 1. Right? So I plot that point on the graph here. All right, so from 0 to pi, my x-coordinates go from 1 to 0 down to negative 1. 1 to 0 down to negative 1. Then, as I move from pi to 3 pi over 2, as I move through the third quadrant of my unit circle, well, now my x-coordinates are starting to increase, right? Because now I'm moving to the right, so my x values are getting bigger. They're still negative as I'm moving through the third quadrant until I get to 3 pi over 2. They get back to an x value of 0. All right, so at 3 pi over 2, I'm going to have an x value of 0, so that's my output here. All right, so I plot that point of 0. And then as I move through the fourth quadrant, right, now I have positive x values when I'm in the fourth quadrant, and they are increasing, right? They're moving to the right until I get back to my starting point, which is at 2 pi. I have an x coordinate of 1. All right, so at 2 pi, my x coordinate is 1. All right, and that's going to be the graph of 1 period of the cosine function. All right, it starts at 1. Remember, for the cosine function, I'm moving around the unit circle and I'm plotting the x coordinates as my y values on the graph. So starting from 0, it goes from 1 down to 0 to -1, back up to 0, back up to +1. And remember, 2 pi is 1 full trip around the circle, so 2 pi is 1 period of my graph. All right, so 1 period of the graph of my cosine function is 2 pi. Right, the trig functions, and I mentioned this when I talked about the graph of the sine function on that other video, but the graphs of trig functions are what we call periodic, which means they repeat the same behaviors over and over and over again, which makes sense because as you're moving around the unit circle, you just keep getting those same x values over and over again, right? You're not going to get anything besides the numbers between -1 and +1 for your x coordinates when you're on the unit circle. All right, so once we go one lap around the unit circle, that's every possibility, every x coordinate that we're going to get. And then as we start moving around the unit circle again, well, it does the same thing, right? We go from 1 down to 0, down to -1, back up to 0, back up to 1, right? So it's going to go back to 0, back down to -1, back to 0, back up to +1, and there's my second period of the graph of the cosine function, right? And if I move in the negative direction, starting at 0 and I go this way, well, it goes from 1 down to 0 to -1, back to 0, and then back up to +1. Right? And it follows that same pattern when I move in the negative direction. And so there's the graph of my cosine function. All right, so this is the graph y equals cosine t, or y equals cosine of x, depending on what variable you want to use there. All right, so a couple things, right? The domain of the cosine function, just like for the sine function, is -infinity to infinity. It stretches in both directions forever because I can keep going around that unit circle over and over again in either direction, and no matter how many times I go around that unit circle, wherever I stop, the point I have is going to have an x coordinate, so it's going to be somewhere on this graph, right? The range of this function, just like for the sine function, is from -1 to +1, including those endpoints. Right? The lowest point I ever reach is -1. The highest point I'm ever going to reach is +1. I'm never going to go above +1 or below -1, because when I'm on the unit circle, as I keep going around and around the circle, the highest x value I ever hit is +1. Right? I never move to the right of that, and the lowest x value I ever hit is -1. I never move to the left of that. Right? So this graph for cosines is going to keep bouncing back and forth between +1 and -1. Right? It has that wave property to it. Right, and like we said, the period of the graph, and I don't know if I mentioned this on the sine function video that I did. I might have mentioned it, but I don't know if I wrote it down. The period of the graph of both sine and cosine is 2 pi, right? Because one full trip around the unit circle, you've covered all the possibilities, and then your next trip around, you just repeat them, and every trip you do around the unit circle, you just keep repeating the same pattern over and over again. All right, so looking at the graph of the sine and cosine functions, if you watch the video that I did on the sine function, they look very similar, right? They're both waves that go back and forth between +1 and -1, right? The difference between them is the sine function, if you recall, started at the origin, right? Because the sine function, we were graphing the y coordinates, so when we had a t value of 0, the y coordinate was 0. So the sine function started at 0 and then went up from there and then kind of followed the same pattern. The cosine function starts at the highest point. All right, so the cosine function starts because when t equals 0, my x coordinate is 1, right? So the sine function starts at like your middle value, right? That mean value of the function is like the technical word for it. But at that middle value, that's where sine starts. The cosine function starts at the maximum value, right? Because it starts all the way to the right when we're talking about the x coordinate, and then goes all the way down and then back around, right? So That's the key difference between those two, knowing that the cosine function starts up at the highest point and the sine function will start at that middle point. All right. They both have the same period. They both have the same domain and range. And like I said on that sine video, you don't have to memorize the graph of the cosine function. Right? The reason I put the unit circle up here and kind of use that to explain how we get the graph. If I just put up the graph of the cosine function and say, okay, here's cosine, memorize this graph and know exactly what it looks like, then you either memorize it or you don't, and if you don't, then you just lost, right? You just don't know how to do it. But if you know where it comes from, right? I'm going around the unit circle. I'm taking the t values. Those pi numbers are my input values. The x coordinates of each point are my outputs that I plot here. If you understand where that comes from, if you forget exactly what cosine looks like, just think of the unit circle and think, okay, when I'm at 0, what's my x coordinate? All right, it's 1, so I start at 0, 1, and then I can just kind of follow the pattern, just plotting the x coordinates going around the unit circle. If you remember that part, you can graph the cosine function without actually memorizing what the graph looks like. All right. So that's the graph of the cosine function. Again, if you haven't seen the video I did on the graph of the sine function, check that one out as well. The next video that I do, I'm going to be talking about transformations of the graphs of sine and cosine. So I'm going to be talking about both of those and doing some examples of them. So you have to know what the parent function looks like. So the parent function for sine, which is on that other video, the parent function for cosine, which is right here, and then we can do shifts up or down or left or right or stretches or shrinks in either direction or reflections, flipping it over. So that's the next thing I'm going to be talking about on my next video.